Hi there. Okay, we got a new project. It's a capacitor meter tester. Okay, so there it is. We try one capacitor here. This is 4.7 microfarad. Okay, it shows 5.54 because plus minus there is a 20% tolerance in capacitors. In this case, this type of capacitors. Okay, so let's take it off. And now we're going to try, I think we're going to try the 100 microfarad. Okay, this is 100. Okay, so let's try the 100 microfarad. You see, I put it correctly. There we are, it's 100 microfarad. As you can see, there is, as I said, there is about 20% tolerance, so it's plus minus. Sometimes can be less than 100. In this case it's 6.40 above 100 microfarad. Okay, so let's try the other one. I'm going to try this one. Not sure what it is. Obviously I can't, it won't take the very big one, but it'll take this type. This is 4.7 microfarad. Okay, so okay. So we put it here and here, and it's 5.11 microfarad. Okay. The reason why, as I said, is because of the 20% tolerance. Okay, let's take it off. Let's try another one. You can also try the ceramic one. There we are. This one is 2.2 microfarad. Okay. Okay, so this one I'm not so sure what it is. Nice. I've already lost it. Okay, so let's have a look at this one. It's doesn't have any writing, so but we can test it and try. I gotta keep the light, take some light off, because otherwise the computer, the screen, the OLED screen flicks. So I gotta put, you can see that there is a shadow on this side, practically here, there is a bit of shade. Okay, so this is 4.7 nanofarad. Okay, so let's try another ceramic one. It's a very small one. I wonder, not sure, I can't even read it, but this will tell us. Oh, this is a big one. A smaller one, but it's big, yeah. It's a 411.4 picofarad. There's got a P. So this is very small, picofarad. Okay, so there we are. It's a PF, and at the bottom here you have the frequency, okay? So the highest the frequency, the smaller is the value of the in farad of the capacitors. Okay, so let's try this one and see what's the frequency. This is an electrolytic one. They are polarized. See, the frequency is 29.36 change the frequency once it's stabilized. This is 2.26 microfarad. Okay, so let's try this one. .17 microfarad. Okay, and there is the frequency at the bottom that changes as well. Let's try another one. Okay, let's see what we got here. Try a ceramic one. What do you think? Let's try a ceramic one. I don't know what is this one because I can't read it. Usually they got numbers like 104. Not sure what it means, but when I... Okay, now... There we are. And that is picofarad. It's 342.9 picofarad. Okay, so yeah. If you want to be 100% sure of what you are using, let's see this one, for example. This is typical. It's got 41.2 written on top of it. Let us see what it is. Yeah, it's 4.7, so 4.6 in nanofarad. All right. And this one might be too big. If it's too big, it'll give us timeout. No, it's 48.7 microfarad. Okay, so this works. Okay. So all right, so also keep in mind here that I put RA ohm and RB. So it's a resistor A, which is 1 kilo ohm, and resistor B, which is 10 kilo ohm. So RA, resistor between VCC and pin number 7, the discharge pin, okay? And RB, it's a resistor between pin 7 and discharge, and the timing node, pin 2 and 6, tied together. Do you understand? The pin node, okay? Okay, so also remember, here we have the constant. It's the frequency of pin 2, as I showed you earlier on. The pin 2, which brings across pin 6, and that will bring the frequency information as well. Once you plug in the positive of the resistor, will show you the frequency. In this case, it will be the pin 2. Okay. All right. So let's have a look. I've switched off now. So let's have a look at the connection. Okay. So we have a 555 timer. Okay. So we have pin number 1, 2, 3, 4, 5, 6, 7, 8. This is the way the pin numbers goes anti-clockwise on the 555 timer. Okay. So we ground pin number 1. Okay, we put it on the ground railing. I made a ground railing, you can see, and I made a VCC railing. Okay, so both sides have the red is a VCC, and the blue it's a negative, it's ground. Okay, so we ground pin number 1, and we VCC, we put it on the positive, pin number 8. Okay. Then we get pin number 4, because you don't want it to reset. You put it on VCC, and then on pin number 2, it's across pin number 6, 5, 6. Okay, so this pin is across. We have a resistor here on VCC. This resistor, it's 1 kilo ohm. You can see it's 1 kilo ohm resistor, and the other resistor it's 10 kilo ohm. Okay, so we have 1 kilo ohm which goes to the VCC, and it goes to pin number 7, and then across with this other resistor. So you have a resistor A and resistor B. So resistor B also from number 7 goes to a wire which is connected to the 555 timer on pin number 6. Okay, pin number 6. This is where we test the positive of the capacitor. And it's got a resistor. Okay, so if you change the resistor, will affect the value of the. So as I said, I calculated, there is a formula for this, and I will show the formula. But this is very clear. It's resistor A, it's 1 kilo ohm. Resistor B, it's 10 kilo ohm. Okay, and remember the shorter legs of the capacitor as the positive. The longer leg is positive, the shorter leg is always negative, and you can see here it will also show the negative with a marker. Okay, that's a shorter leg. So, and the tester goes to pin number, to the resistor, and the pin number 7. Okay, sorry, 6, pin number 6. Then we have the output, which is pin number 3 of the 555 timer, goes to D2 of the Arduino Nano. Okay, Arduino Nano is a chip so that it can read the information and display on the OLED screen. Correct. And as you can see, it will flick now because and that is this capacitor's the value. Okay, looks pretty simple. Let's try another capacitor, this blue one. Wow, this blue one is nice. Look big, but it's not. Let's see what is the value of the blue one. It's 5.5 microfarad. Okay, so remember the output is pin number 3. This is where I usually put a LED to flip-flop or to blink when you use the 555 timer without the chip. So there goes to pin number 2. Let me show you pin number 2 with a magnify so that you can. We can put it closer. Yeah, there we are. See, pin number 2. Pin number 2 go to pin number 3 of the 555 timer. Okay, so I think we covered everything here. Data cable for the OLED screen. And as you see, it will be the SDA goes to analog 4, pin analog 4, and analog 5 goes to ACL. Okay, remember this. But this does not need to be, can work with a ESP, any ESP, and can work with, just with the ESP you have to be careful the wiring, but yeah, there shouldn't be any problem. And it's the same coding, I'm sure. But it will work with any Arduino chip. Okay, so this is very important. Also, you can see here I put a ceramic capacitor on pin number 5 to the ground, just for noise, to clear no electrical noise. Okay, it does help a bit, and that's it. Usually pin number 5 on the 555 timer is always grounded, so to avoid electrical noise. And that because if you plug this one into an oscilloscope, you will pick up, it will show you the electrical noise, and it'll show when it clears them out as well. Okay, so also remember here we have the constant. It's the frequency of pin 2, as I showed you earlier on, the pin 2 which brings across pin 6, and that will bring the frequency information as well. Once you plug in the positive of the resistor, will show you the frequency. In this case it will be the pin 2. Okay, thank you, bye.